Hey everybody, and welcome back to Algebra 2 Online. So today the plan is to talk about systems of inequalities, and we'll look at examples, and one of the things I want to make sure you can do is both given given inequalities, get the answer, and you'll see that that's done by giving it in a picture format. And also, I want to make sure that if I give you a picture format, that you can write the inequalities. So we'll do both of those today. But just sort of as a warm-up, I want to talk about these three. So it's important to know when to use certain methods when you're solving systems of equations. I don't want you to just feel comfortable with one and just use one all the time. For example, the first one, these right here, the 2x and the 4x, are common multiples, right? And the fact that I don't have a variable that's super quick and easy to solve for would really mean that elimination would be best. If you tried to solve for any variable here, you're going to get some weird decimals and things like that. So doing elimination on that one would be best. On this one, though, that x is all alone, we could just solve the second equation as x equals 12 plus 3y, and that would mean then we could take that and we could put it in right there. So this would be a good one for substitution. The last one is kind of different because you have this, which kind of screams substitution, but you also have like common multiple here, and that means you could do elimination. This is one where both would be good. I really don't think there's one that's easier here. That's one where I would say whichever one you think you're more comfortable with, you should do. So systems of inequalities, basically the idea is we need to find the area of overlap between the two graphs. So the solution is I'm just going to call it the overlapping shaded area. So we'll basically graph like this, 2x minus 1. Inequality, and then we'll graph this inequality. And that's just like the end of Unit 2, graphing inequalities. And then we'll look at them on the same, graph, and we're basically just thinking of these together, and whatever works for both will be the answer. So graphing 2x minus 4, we would get the following. So we get that region for y bigger than 2x minus 4. And then for y less than or equal to negative 0.5x plus 3, we would get this region. And so the answer to this, the overlapping shaded area, would basically be everything, kind of in this chunk right here. So that red area is your answer. And you literally just have to do these on a graph. There's no other way. A weird thing that happens is if there is an answer, then typically, and I'll show you an example where it's not, but typically you get infinite amount of solutions, right? Because in this region in here, there's an infinite amount of points. And you could do the same thing we did with inequalities before, like you could pick this point, what is that, negative 5, 0. And negative 5, 0, if you plug it in for x and y, it should make both of those inequalities true. But if you take something like, I don't know, how about maybe something like this point 0, 5. 0, 5 would be good in here, but it'd be bad in here. It wouldn't work in that one. So you can kind of check it that way, but the easiest way to write the answer is honestly just to make the shaded area like really, really, really bold. Like whatever you want the final answer to be, just like make that really bold and clear to me. And if you're ever unsure if it's clear enough, I could always just, you could say, is this clear? And I'll show you my work, and then I could say yes or no. But something like that would be very clear that the red area is the answer. So I'm going to do the same thing, and this one kind of has a weird answer. So that -1 is going to shift it to the right, and it's just shifting that step function, that floor function, to the right. So normally it starts at the origin, but now we're going to start right here, and we're going to have that, and then it just steps up like this, forever and ever and ever, and it also steps down like that. We'll do one more. It just keeps going. And the other one, so I'm not going to shade yet because of a certain reason. The absolute value one, we have a shift to the right too, and it's upside down. So we've got, like this point is on, so normally we'd have the V here. We shift to the right, so now the vertex is right there, and then it's going to go down. So we have like this point, and then it's got slopes of 1 or -1 on either side, so like that. And you got to be careful, this one's dotted, okay? And now for shading, you shade below this one, and you shade above this one, right? So you get that. And if you remember, this point in here was open for the red floor function, but, and we kind of look like we filled it in with the purple, but the purple is really dotted. I'm just doing that to like get the template sort of the shape of the graph. So really, there is no overlap right here. This is like a one-dimensional barrier between the shaded stuff here and the shaded stuff here. So this is a problem actually where there is no solution because there is no overlap between the two graphs. Which is kind of weird, but you can definitely get that. So just like I was saying before, I want to make sure you can write inequalities given pictures. So I've got, there is a system of equations here, or systems of, not equations, but inequalities. And if you look at the green one, let's start with that. This green one right here, this is the green area kind of all over here, right? It's dotted, and it's a vertical line, which vertical lines are always written X, right? And we're shading to the right, so it's greater than, and the point it goes through is 1. So that's one of them. And we'll do maybe the red one next. So red one is also not equal to, and it's an absolute value, and really it's just our normal absolute value. So we would just say y is less than the absolute value of x. And then last but not least, I'll do gray, and this is just a line, and it has a y-intercept you can see of 8 and up here, right? And it's got a slope of down 2 over 1, down 2 over 1. So that negative, whoops, I should put in the inequality part. So we have y is less than or equal to negative 2x plus 8. And that'd be it. So like if you graphed this, you would get this kind of region. And it's good to talk about what the solution to this would be. And the solution would basically be this weird thing. Like if I asked you to solve that system of equations, it would give you, this line, and then everything kind of below the line, over to this dotted line, and then up to this dotted line. And that would actually just continue like down off the page. It goes forever, kind of infinitely down like that. But that would be the solution.